All right, so let's look at the hamburger problem from class today, and I'm going to go back to the problem that we had as well earlier when we had the infinite many solutions and show you how to write what you're doing. So I went through and did the RREF on our matrices here. Got the following as follows, and again as we look at it. Really, when the bottom, it could be any row, but when I look at the bottom row here, there's a contradictory here with, 0z equals 1, and so therefore 0 equals 1, and we know that's not true. Okay, we could take the first equation. And the first line, we could say, well, that's x plus y equals 0, and that's still a linear function. And the second equation, I can say, well, z is equal to 0. Well, again, we have the contradiction down below that, hey, 0 can't equal 1, and therefore that's why we would say it'd be not possible, and therefore no solution. I was also just looking at it, just the wording of it, and it kind of gave me the indicator of why this one was no solution. Was it said the second person got one hamburger, one fry, and a soda for $5, and the third person got one hamburger and a fry for $5. So you get two people ordering two of the same things, and one orders one more item, and they're paying the same amount of money, which to me is like, okay, that just doesn't make sense. Why would I get a hamburger and a fry and pay $5 when I could have gotten a hamburger, a fry, and soda, paid the exact same amount? So that's why, in a way, like when we think common sense, well, that's really why it's a no solution. That doesn't kind of balance. And then let's scoot up here and look at the problem on number 56 when Paige and Maisie were talking about, okay, they both got this answer after getting done the RREF, and this was one of those infinite many solutions. And it's a matter, and this is mainly how do you type it into Pearson is what we're looking at. And you can do this for a test too. This is not a hard thing to do. So how do we need to type it in for Pearson's sakes? Well, we start with the bottom line, and that tells us since 0 is equal to 0, then in our ordered pair, the z is our main is a variable there, and that's what variable needs to be in each of the other parts. So as I go to the equation above it, we get to say y plus z equals 4. And now I know the second term in it, and the ordered pair is the y value. So I'm just going to solve that for y. So I'm going to subtract z from both sides. And I find out that y is equal to 4 minus z. So I can just put 4 minus z into that location of the ordered pair. Now the first one did not have a z at all. It's technically 1x plus 0y plus 0z equals 2. So this one just simplifies to be x is 2. So the first ordered pair isn't an equation, it's just a physical number. It's just going to be 2. And so that's how we can create this. And this, again, this will indicate that, hey, infinite many solutions. There's going to be a line that we'll be able to, once we know what the z value is, we can go ahead and figure out what the answer is, and really any z value is going to work because it's always going to be 2 units to the right, on the x-axis, and then it's just a matter of adjusting based on whatever z is.